Hello and welcome. Thanks for joining me for yet another exciting tutorial. Let's review the goals of this tutorial. We will be creating a route. We will then apply a measure or measurement to this route. We will then display the route using hatches or hatch marks. And finally, we will use the Route Identify tool to facilitate the generation or creation of new addresses for structures along a road or route. We will be using an ArcView license of ArcGIS Desktop, version 10.x, although this same task of generating a route can be performed in version 9. Keep in mind that we will be generating a simple route, not a network. Therefore, we will not be using the Network Analyst extension. The foundation of this tutorial rests on the concept or idea of generating an address using what is known as the frontage interval system. This image, collected as part of the National Agriculture Imagery Program, or NAIP, is for a rural area in the western United States. Road center lines and the locations of structures have been mapped with GPS and have been integrated into a file geodatabase as part of ArcGIS Desktop. Note the representation of the road center lines. The roads are represented with a linear feature, a line or polyline. Note that the structure locations, such as homes or businesses, are represented as point features. We will assume that every road has an origin or place of beginning. For example, this road, called Airport Road, begins at the intersection with this other road. Each road or linear feature also has a direction. The direction of the road is away from the origin. We will be implementing the frontage interval addressing system for this area. Well, how does this frontage interval system work? The frontage interval system exercises a measure based on actual road distance to determine a unique address number. Address numbers will be assigned at an interval of 100 per mile. Therefore, a structure located 1/2 mile down a road would have an address of either 50 or 51, depending on what side of the road it was on. In this example, we're using the location where a driveway intersects a main road for the determination of address assignment. For example, even numbers, 2, 10, 20, 40, could be assigned to structures on the right-hand side of the road. Now remember, we can distinguish between right and left because we're traveling down that road based on a direction. Odd numbers could be assigned to structures on the left-hand side of the road. Imagine you're at the beginning of this road and you reset the odometer in your vehicle. There's a good possibility that you could locate an address, such as 200 Airport Road, by traveling 2 miles down the road and then looking to the right. Now, we all know that a GIS stores a representation of the real world. That being said, let's take a look at an issue as it relates to distance. We need to keep in mind that changes in elevation or topography partly define a road's length. In this simple example, a road traverses across a very flat surface. If we were to represent this road or road centerline in the GIS using a vector-based line or a polyline, the length of this line, as stored as an attribute in the attribute table, would be a close approximation to the true length of this linear feature. Now, let's take a look at a potential issue. In this simple example, we're dealing with a road that traverses a landscape that has quite a bit of variation in topography and or elevation. In this orthographic view, also known as an ortho view, we're using a 2-dimensional drawing to represent or describe a 3-dimensional landscape. Okay, so here is an overview of the problem or issue. If we installed a distance measuring instrument, also known as a DMI, we would be able to drive the length of this road and determine its true length. Now, typically with a DMI, there's a transmission sensor which is hooked up to the wheels of a vehicle. The wheels are calibrated so that their rotation can be used to compute or determine the distance driven. If we were to digitize a representation of this road or use a non-DMI enabled GPS receiver to map the traverse of the road, the true length of this feature probably would not be represented accurately as an attribute in the GIS because it doesn't take into account the variations in topography. The true distance, 5,188 meters, is greater than the length of a polyline that was digitized from an ortho-rectified image. Why is it important to consider this difference or delta in the measurement? If the roads in our project area belt or traverse a wide variety of topography, And if we digitize these roads without taking into account this variation in topography, the length of the roads represented in the GIS will probably be less than the actual length. Therefore, addresses generated with this uncalibrated route represented in the virtual planimetric GIS realm quite possibly will fall short of an address generated using a DMI. So at least keep that in mind. Now imagine somebody mapped the locations of mile markers, or they recorded the actual mileage for a new route. Tools exist in the realm of ArcGIS Desktop to facilitate the calibration of a route based on this mileage information. Mapped locations of mile markers certainly can be used to calibrate a route. Mile markers can be captured as point features and then snapped to the linear features representing roads. Values stored in the mile marker attribute table can then be used to calibrate the route. All right, let's get back on track. Or maybe we should get back on the road. Anyways, the ultimate goal of this project is to generate a route. We will use the route to generate new addresses along a road, because the addresses will be generated based on a down-road distance. Emergency response crews could locate a structure based on an address. And yes, the pizza delivery person would probably find the addresses useful as well. Before we dive into this project and start using ArcGIS Desktop to create a route, let's take a look at a few definitions of a route. There really isn't anything overly special about a route. A route, by definition, is a vector line feature or polyline, such as a road, pipeline, stream, or river, that is made up of a system of measurement and a unique identifier. As we will see shortly as we're using ArcGIS Desktop, this route identifier is pretty important. Sometimes it's easy to forget about this route identifier, so keep that in mind as we move through this tutorial. Keep in mind, too, that routes are stored in a route feature class. An important aspect of a route is an M value. We can think of M values as simple measure values stored in the vertices of a feature. These measure values or M values can then be used to measure the distance along a linear feature. Recall that a polyline is a linear feature which is often referred to as a path, and a polyline, poly meaning many, is made up of multiple path series connected by a vertex or vertices. When we edit or create route features, we modify both the spatial geometry of the route, the linear feature, and we edit or modify the measures or the M values stored in the route. Many applications that use linear features, such as rivers or roads, can benefit from this linear referencing system. One of the cool aspects of linear referencing is we can associate attributes to a portion of linear features without having to split or segment those features each time that attribute value changes. For example, linear referencing could be used to store and represent the changes in surface type along a road feature class. A linear measurement system can be used to manage the locations of signs or bridges in the realm of hydrology, specifically the mapping of rivers. Routes can be used for river addressing. A river, a linear feature, can be dynamically segmented, and this linear referencing can be used to manage or address objects along that river, such as a monitoring location. Now, in this tutorial, we're going to keep it simple and use a route to generate addresses, though we will not be assigning attributes to a portion of a line based on linear referencing. All right, let's get started and make it happen. I've opened a fresh copy of ArcMap. We'll open up the catalog window from within ArcMap, and we'll add a new folder connection so we can access the geographic information assets that are part of this project. We'll connect to a folder by first clicking on this icon. We could also right-click on Folder Connections and choose Connect to Folder. I will navigate to a folder on the hard drive called Routes, and then click OK to connect to that folder. After expanding the folder connection in the catalog window, we observe a geodatabase represented with this small can and two images. The geodatabase is comprised of two feature datasets, namely structures and facilities and transportation. Each of the feature datasets contain a single feature class, namely structures and roads. We'll add the road feature class to our project by dragging it from the catalog window to the display area. After adjusting our map scale by zooming into this area, let's modify the symbol used to represent the roads. We'll invoke the symbol selector and we'll choose major road as the symbol. Next, we'll add the structure feature class to our map display. Let's invoke the symbol selector by double-clicking on the existing symbol and modify the symbol used to represent the structures. We'll choose a green triangle and then adjust the size. Click OK to apply these changes. All right, looking good. We will also add the NAIP_007B.SID image as a reference. Let's auto-hide the catalog window by clicking on this small push pin. All right, we have somewhat of an issue here. The image does not look very good, at least in my opinion. Let's use a standard deviation to stretch the range of levels stored in this image so that the colors are clearer. Let's invoke the Layer Properties dialog box for this image. Right-click on the image and choose Properties, and then make the Symbology tab active. Next to the phrase stretch, we'll set the type to standard deviation and enter a value. Let me see, what would be best? Let's try an n value of 3, and then apply these changes, and then click OK. All right, that looks a little bit more natural. Perfect. I will reposition the image in the table of contents so it draws first. We have added to our project the foundation layers, or geographic information assets, that will help us through this project. One of the goals of this project is to create a route. Let's create a placeholder or container to store the routes. In other words, we'll be creating a new feature class, a route feature class, to store the routes. All right, let's reinvoke the catalog window. We'll store the new feature class in the transportation feature dataset. Right-click on the transportation feature dataset and choose New Feature Class. We will name this feature class Routes and enter an alias of Routes for Rural Addressing. The type of feature stored in this feature class will be linear features, or lines or polylines. Under the phrase Geometry Properties, we'll place a checkbox next to Coordinates Include an M value, because this is a route and the M values will be used to store measures. We will retain the default M tolerance. Click Next. Now remember, we need to include a route identification number, so we'll enter a field name of route ID and then set the data type to a long integer. Because we're creating this new spatial asset from within the catalog window in ArcMap, this new route feature is added to the table of contents automatically. Let's modify the color of the symbol used to represent the routes. We'll make it a red or orange color, and then we'll auto-hide the catalog window. Next, we'll add 2 additional toolbars to the ArcMap interface, specifically the Editor toolbar and the Route Editing toolbar. From the main menu, we'll choose Customize, Toolbars, and then we'll select the appropriate toolbars from the list. We will be using the existing road features to create a route. We'll start with Airport Road. One option we have is to begin an edit session and then select all of the features that comprise or make up Airport Road. This would be a fairly time-consuming task. Instead, let's select all roads that meet a certain criteria. In other words, we'll select all road features that have a full name of Airport Road. To perform a select by attribute, we'll first open the attribute table of the road feature class. Right-click on the asset in the table of contents and choose Open Attribute Table. Next, click the Select by Attribute icon or tool. Let's build a simple where clause to select records in this table, where the full name is equal to, we'll click Get Unique Values, and then select Airport Road. After applying these changes and instructing the table view to show only those selected records, we observe that 16 records have been selected. The linear features, shown in cyan, are selected as well. We want to make sure we selected the one and only Airport Road. Let's zoom to the selected features, and sure enough, there is only one occurrence of Airport Road, although it is made up of multiple line segments. All right, very good. We have all of the segments that make up Airport Road selected. We'll use these selected features to create the route. From the Route Editor toolbar, we'll click on this small icon, which will facilitate making a route, or Make Route. From the Make Route dialog box, we need to click on the start point of our route. We'll click on this small icon first. Note the cursor snaps to the endpoints of the lines, or the vertices making up the polyline. We'll click here and this will establish the start of our road. Next, we need to specify how the measure values will be obtained. We'll use the inherent geometric length for this. Alright, this is where it gets a little tricky, though not too complicated. We need to multiply measures by a certain value to accommodate 100 addresses per mile. View one method of coming up with the number or factor that we will multiply the measures by. We know that there are 5,280 feet per mile. To convert feet to meters, we multiply the feet value by 0.3048. If our goal is to generate 100 addresses per mile, we'll establish the dividend and divisor and come up with a quotient. In other words, we will divide 5,280 feet by 100, resulting in 52.8. We multiply 52.8 by the feet to meter conversion factor, we end up with a value of 16.09344. We then calculate the inverse of this number, 1 divided by 16.09344. The result is what we will multiply our measures by, 0.062137,119. Why did we need to use the feet to meters conversion factor of 0.3048? Let's make the Layer Properties dialog box active for the Road feature class. After making the Source tab active, we observe that the linear unit for this spatial asset is in meters. And in addition, if we view the data frame properties, we observe that the map units are set to meters. Make sure you are aware of the units of the spatial assets you're using in your project. Alright, we're back to the Make Route dialog box. In the entry of Multiply Measure By, let's enter the value we just calculated of 0.062137,119. We'll keep the start measure to 0 and ignore spatial gaps. Alright, next, click on the Make Route button to create a route for Airport Road. From the Editor toolbar, we'll stop the editing process and save our changes. Recall that we added a field called Route ID to our Route feature class. By default, this value is populated with a value of 0. Let's modify the value so it is the same as the object ID. Alright, once again, we need to start the editing process, and then we'll open the table for the routes, and then populate the Route ID with a value of 1. Stop the editing process and save our changes. Next, let's display the route using hatches or hatch marks. And apparently, these hatches have nothing to do with eggs or chickens. Nonetheless, we'll open the Layer Properties dialog box for the routes, make the Hatches tab active. Don't forget to place a checkbox next to Hatch Features in this layer. We'll set the hatch interval for the major hatch to 1, and set the minor hatch to place a hatch mark at every 5 hatch intervals. We'll use a line feature and set the length of that hatch line to be about 20 meters. In addition to the hatches, let's place a number next to the hatch. We'll place a checkbox here to label these hatches, and then modify the symbol or the number and make it a little smaller. In this preview window, we observe that the numbers have a precision, for example 5.0, and we don't necessarily need this decimal point. Let's modify this label setting and remove the decimal point. We'll click on the Label Settings button. Adjacent to the phrase Precision of Numbers and Text, we'll use this pull-down menu and choose 0. After applying these changes, we should hopefully observe both numbers and hatch marks along our new route. Excellent. The hatch marks and the hatch value indicators are visible. Let's take a look at an example of calculating a new address for a structure along a route. After making the Identify Route tool active, we can click on the route at the point where the driveway intersects the road. The measure value is echoed at 125.959. Because the structure is on the left-hand side of the road, we could assign a value of 125 or 127 as an address. It is approximately 1.26 miles from the origin of the road. Let's verify that our coefficients and multiplication values are correct. Here's the idea. I'm going to mount a very small GPS receiver on the back of this snail, and then as the snail traverses the road, it'll collect the full... Wait, I have a better idea. Instead, let's generate a new line segment that is exactly 1 mile long. We'll generate a route for that line, display the route using hatch marks. If our calculations are correct, the start of the route should show a value of 0, and the end should show a hatch of 100. From the Editor toolbar, we'll begin the editing process. And from the Create Features dialog box, we'll verify that we have a feature template for roads. Next, we'll make the Straight Segment tool active to generate the new line segment. We'll click the left mouse button at the starting location of our line. If we want to create a line with an exact length, press and hold Ctrl L on the keyboard. Because the units of our spatial referencing system are in meters, we'll enter a value of 1609.344 as our length, which is 1 mile. Note that the length of our line is now static. In other words, it's set to exactly 1 mile. We'll click with the left mouse button to create this line segment. Right-click and choose Finish Sketch, or use the keyboard shortcut and tap on the F2 key. Next, we'll create a route or make a route from the selected feature. From the Route Editing toolbar, click on the Make Route tool. We'll need to specify the start of our route. I will click here. We will enter a multiply measure by of 0.062137119 and begin our measurements at 0. Click Make Route to generate the route. Because we've already established hatch marks for this geographic information asset, the hatches appear automatically. Sure enough, the beginning of our route is at 0 and the end is hatched at 100. In this example, we used a route to facilitate the generation of addresses using the frontage interval system. Routes can be beneficial for many projects, so keep that in mind as you're working through your projects. Before we wrap up this tutorial, let's look at an option for updating attributes and selecting and deleting a route. To select a route, make the Editor tool active and place a cursor or pointer on the existing route. Because the route occupies the same geographic space as the road source we used to create the route, this nifty little icon appears showing that more than one feature has been selected. In this example, both the route and the road have been selected. Using our pointer, if we select or click on the small arrow to the right of the icon, we observe the two selected features. After selecting the route from the drop-down list, using the pointer, right-click on the selected features and choose Attributes. This will invoke the Attributes dialog box. We can then place the cursor to the right of the existing Route ID field and populate it with an appropriate value. If we want to delete the route, we select it from this pull-down list. It then becomes the selected feature. Sure, there are many options for deleting this route. One option is from the main menu, choose Edit, and then select Delete. After deleting a route with hatches, you may note that remnants of the hatches still remain on the screen. You may need to tap on the F5 key or choose Refresh from the main menu to dissipate the remnants of the route and the hatching. Hey, it was nice to have your company during this short tutorial. Oh yeah, and by the way, if you are learning ArcGIS Desktop, or if you are looking for a comprehensive course to provide the groundwork for becoming a very productive ArcGIS Desktop user, please check out our complete training series called NoGIS. The training is available for both ArcGIS Desktop version 9 and ArcGIS Desktop version 10. NoGIS 10 consists of about 16 hours of material. Anyways, hey, thanks again, and I wish you the very best. Take care.